Absolutely, exactly. Yep, and that's part. I think that's one reason why some people do not do their screen recording, or at least not make it available to the public. Is they don't want their peers or supervisor to see how they teach a class.
Be judged.
I'm not gonna teach the class any differently. When I'm being reviewed or evaluated.
So like here.
In fact, it's coming up this fall. Okay, so yeah. All right. So let's go ahead and get started. I don't have my roll sheet today, so I'm hoping that no one's gonna walk out of the classroom like right now. It's like, okay, there's no roll sheet today. I can take an early lunch. All right. So what I'll do today is to do the usual thing. We go to the Power Server, take a look at the WordPress. Not too many exciting things. Ubuntu phones, that's kind of interesting because for those of you who don't know what Ubuntu is, it's a distribution of Linux. So we are now starting to have a true Linux distribution installed on a phone instead of Android, which is kind of like an application framework on top of Linux. Okay. So are there any questions about Ubuntu phones? I think they will run up against certain types of obstacles. For instance, it won't have the apps because it cannot run Android apps. Okay, so that's both a good thing and a bad thing for these Ubuntu phones. They will basically be targeting people who do not want to use Android apps, but they want to use native Linux applications. So that's going to be interesting. I think it would be interesting to see how this plays out. Because if you compare iOS to Android, which one is more restrictive as to what type of application you can run? iOS is more restrictive, Android is kind of more open, right? You can actually turn on an Android device and say, I want to be able to install from a file, and most Android devices can let you install any application from an APK file. So your friend can send you an APK file, you can install it, and you're done. You don't have to install it directly from the Play Store. This is even more open because it means you have administrative access. Okay, and you can basically install whatever package you want to install from the Ubuntu repository. So it'll be kind of interesting to find out, how it's going to compete with iOS and also the Android platforms. I don't think it will be competing with Windows at all. Yep.
Doesn't that make it less user-friendly though?
It all depends. It all depends on what type of user interface they will be using, with Ubuntu. The nice thing about Ubuntu is it is much more open source than Android. So that means more people can actually contribute to try to make it more user friendly. So it's going to be interesting. It's going to be a very interesting contender on top of iOS and Android. This one is also kind of interesting, especially for those of you who like robotics, because it has nothing to do with robots playing soccer. Instead, it has to do with robots keeping an eye on soccer fans and troublemakers. So they will be deploying. Chatbots will be deployed in Brazil during the 2014 World Cup soccer season, and they might have mentioned how many of these robots will be deployed. These are the very same robots that they deployed in the military. So these are pretty hardy, robust robots. They can survive a fall from 2 meters onto concrete. That's like from this kind of height, you can drop it onto concrete and it's okay. You can throw it into the window of a building and it's okay. You can fall down the stairs and it will still be okay. Okay, so we are not talking about tiny little remote control cars with cameras. We are talking about military hardware here, and they're going to deploy these in Brazil during the soccer game. Not playing soccers. So it will be interesting to see how these things are actually utilized. And then for those of you who are really interested in how robots play soccer, here's another link. Now that is nothing new, okay? Robots playing soccer is nothing new, but what this one is kind of special is it's a learning robot, okay? These are autonomous robots that can also learn while they're playing. So that's kind of interesting. And they're humanoids too. Humanoid robots are much harder to control as compared to the wheeled ones. Because now you have a lot of joints, you have coordination, you have to do the balancing and stuff like that. So that's kind of interesting. So are there any questions?
Is there a video that you watch it? Just a quick little sneak peek.
There's probably a one somewhere. Right here, maybe.
Hello, so welcome to the Global Virtual Lecture Hall. This is the very last lecture of this series, this fall term of the Shanghai lectures. So please stay tuned for this lecture. So
Nope, there's no robot actually playing. Yeah, just the presentation of the topics. But it's still interesting because AI died, in about, I think between the late 90s, the late 80s, okay, early 90s to I would say maybe mid 2000. I think AI basically was dead. Artificial intelligence was basically dead at that time. But now there are more people interested in AI again, artificial intelligence, and making things autonomous. So that's kind of encouraging. Go ahead. Okay. So that's kind of cool. You can probably just go to YouTube and find and just type in robot soccer. You will find a lot of video clips, everything from way back in the past to the current ones, and it's amazing what they can do with robots. And those are all fully autonomous. We are not talking about somebody or a team of people remotely controlling these robots. These robots are actually thinking and acting on their own to play soccer as a team. Okay, it's not just one robot trying to get a ball to the goal. It's a whole team. There'll be like defenders and and the whole 9 yard. So it's interesting. Yep.
Start like knocking each other over and stuff.
That will be American football. But they do blocks. I mean, they actually do amazing strategies to block each other and try to dribble, pass the ball, and all kinds of stuff. And they're only about yay big. Yep. All right. So getting back to the topic here. Oh, the other day, let me go back to the nested homework assignment first. So what I did with the previous class was I postponed the due date. So I'm going to do the same thing here in this class. Wait, this is not the, nope, not the right class, sorry. 10:30. There we go. Okay, so what I did with the previous class was I postponed the due date of the nested homework assignment, the nested statements homework assignment. But it was postponed in a way where you still have to turn in something on Tuesday. So let me open it up first. All right. Okay, remember this? The first thing you have to do with this homework assignment is to structure it correctly with the right indentation. That's the first thing you have to do. So with my previous class, with the 9 o'clock class, I turned the homework assignment into 2 parts. The first part is just the indentation, which is due on Tuesday. So you don't have to trace it on Tuesday. By Tuesday, you have to turn in the version that is indented with the structure correctly identified. And then on Thursday, you have to turn in the actual trace. So it would I would turn this into 2 separate homework assignments. Are there any questions about this? Any complaints and say, but I'm done with it already. I want to turn it in now. Yeah.
Can you just do both?
Yeah, you can do both. Then you don't have to turn in anything on Tuesday.
You mean on Thursday? You mean on Thursday?
On Thursday, right. So on Tuesday, you have to turn in at least the part that is indented. And then on Thursday, you have to turn in both parts. Are there any questions about this one? Because my 9 o'clock class, seem to have quite a few questions about how to do the indentation, or where's the beginning of one construct and the end of the same construct.
We went over that last class.
Yeah, we went over some of those, but I went over that also in my 9 o'clock class. Yep. also. So
How
that's
do
why I
you
wanted-
do the automatic indentation again? You click on the toolbar or?
The arrow key.
Was
Yeah.
that the recording that was discontinued?
Yeah.
On Tuesday, we have a part of the lecture discontinued because the screen just went dead. But that was not the part that relate to the homework assignment. That's already into the part where when we talk about pre and post conditions, I think.
And then we went into Bulgar algebra or something like
Sorry?
that. So, that one
Boolean
type-
algebra.
Boolean.
Yep. All right. So to indent a block, I chose two blocks that are.
Okay.
So you just use this tool to indent,
Okay.
and then to unindent, you can use decrease indent, which is this tool here.
Okay.
Okay. And let me just double check that it's actually recording right now. Yep, it is. Okay. That's good. All right. So are there any questions about the indentation part of this homework assignment? No questions? Okay, go ahead.
How did you select just two and not on that?
You can do a control click.
Oh, control click. Okay.
Yeah, if you use control click, you can you can basically just control click any
Okay.
cell, and as long as they are selected, when you perform an operation like indentation, it will be applied to all of them. And obviously, this is not the right part to indent.
This was
I just randomly picked something to indent. Yep, go ahead.
this is the lecture where you suggested we start from the inside out.
There are many ways to do it. One way to do it is from the inside out. Find out the portion that has nothing nested inside and start with that part. You can also start from the outside in. It all depends on how you work, basically. But there's no one single way to do it. There are many ways to do this homework assignment. Okay. Any other questions? Go ahead.
If you're doing the if and the end if and you're indenting it, if there's an else in there, does the else get indented with it, or does it?
No, the else stays at the same indentation level as the if and the end if. Yep.
I already did it and submitted it. Do I have to submit it again?
Unless you have any type of correction, if you think there's no correction you need to do, you can just let it sit there the same way it is. Okay. Any other questions? If there are no questions, that's interesting because this class is just moving ahead so much faster than the other class.
Maybe because I'm more awake.
Maybe, or maybe nobody has even tried except for you, and that's why there's no questions. Like, do we have any questions? No, I haven't even started yet. So I am hoping that's not the reason why we are not seeing any questions in this class. No questions for the wrong reasons, right?
I have a
Yep.
question.
Yep.
So in the example you gave us, it was two while statements.
Right.
And here we have a while and then a if then else. With in between the very middle, 7, 8, 9 lines, would you indent those under the else and then else under the if and then
Okay.
if under the while?
All right. So we do have questions. Very good. So the way I do this is I use parentheses or I use some way to help me take a look at where are the beginning and the ending of the constructs. So the way one way to do it, okay, many ways to do the same thing, is when you see a while, you say open. When you see if, you say open. When you see if, you say open. When you see end if, you say close. End if close, end while close. So this gives you an idea of how the actual nesting of the statements, because we already know how to read open and close parentheses, right? So that makes it easier because it relates to something that we already know, how to read in terms of the nesting levels. So that's one way you can, one thing you can do to help yourself, when you're trying to work out the code. Did I answer that question or?
Absolutely.
Okay, excellent. All right, so if there are no questions about this, and since we're kind of a little bit ahead of the other class, I'm going to ask you something that is not directly related to algorithms or problem solving, but rather, how do you compare face-to-face classes with online classes? So for those of you who have taken online classes, how do you compare the two, and do you think there are ways to make online classes having the same effectiveness as face-to-face classes?
Live chat rooms would be awesome.
Live chat rooms. So you want basically what we call synchronous communication, where you can get a response back from the professor or the rest of the class in real time instead of waiting for the email to be replied?
When I was taking Japanese 3 in high school, the teacher left really early in the year, and so we had to do something like that, and we actually had it set up where we could chat with other people in the thing and such, and talk and all that.
And that was helpful?
Yeah, but it was a lot easier to just find yourself not doing what you're supposed to do.
I'm taking a Japanese class, and that's why I'm watching Japanese anime in Japanese with subtitles, right? Yep.
I think a video lecture would also be helpful because sometimes with online classes they just assign a bunch of written material and it's like, what's the most important? I have no idea, and then they test you on it.
Okay. Yep.
In my experience, it's all on your comprehension. Whatever subject it is, if you don't understand it, that's where face-to-face helps because the teacher is there to clarify or to clear anything up that you don't really understand from reading. So basically what you're doing online is studying yourself.
Okay, well that's good because what you just did was to identify one of the common issues with an online class is interaction is a little bit more difficult or less effective compared to a face-to-face class. Because you can just ask me a question and I can respond back within seconds, right? I can start to respond to it within seconds. Whereas with an online class, you ask a question, the professor will come back to you even within a day. But if that did not answer your question, then it would take another day for the follow-up, right? But in a class, it's just like ping-ponging. We can get the whole thing done in 2 or 3 minutes. Other students can also contribute in a class setting, but in an online class you have forums too, so if necessary or if it is equipped, you can also use online forums for that purpose. But are there any ways to make an online class as effective as a face-to-face class? That really is what I'm asking.
I think it depends on the person. I have a hard time doing an online class because just remembering to log in every specific time for it, it's just it's difficult. But when I have somewhere I have to go from time to time, so I think it kind of depends on the person. Either you're able to do online classes or you can't. So if you can't do them, it doesn't matter what, to a degree, what you change.
Okay, go ahead.
Or like the way you record these, if like you make it a class, like say this semester you record them, next semester you make a class so they can watch them whenever they want. And like I feel like it's the same as being in class.
It feels about the same, but it's not interactive because even though in the video I record questions from the class and my response to those questions, you can't really ask me questions when you're watching the video. So you're kind of still relying on your fellow students to kind of ask the clarifying questions and make sure that that covers everything that you need to know. Yep, go ahead.
I agree. I think it's better to have a personality. If you've ever watched like the math from the Khan Academy on YouTube, there's something nice about listening to Khan talk to you. It seems personal. It's easier to understand a lot of times, and it's much different than just reading a flat, dead textbook.
But that has to do with learning style because some people learn more from auditory, senses and visual, or from reading a book. Some people are more hands-on. Other people are more, abstract. I need to learn the rules first before I actually start to do something. Some people want to do something first, and then from that, they want to learn the rules or the mechanism of what they're supposed to learn. So it depends a lot on your learning style. The reason why I'm asking this question is because I am a part of the distance education subcommittee of the curriculum committee of this campus.
That's a mouthful.
Yeah, that is a mouthful. And it's amazing that I can actually say it. And as a part of being part of that committee, we are currently trying to write a policy for the entire campus here as far as the minimum interaction is concerned with online classes. What is the type and the frequency of minimum online communication between the professor and the students in an online class that is necessary to make the class effective to the point where it is as effective as a face-to-face class.
Last semester, or the semester before last, I took hybrid classes, and that kind of helped in that area because we only went to school for about once or twice a month. So before any assignments were due, we would get in class, we would gather the questions, we would talk with the instructor, and we would just make sure everything was good to go before you actually take the test. So it covers all of the reading material. You do everything at home, just like an online class. But then if you do have questions, you have a whole day to go through and cover everything.
But during that day when you're actually on campus, what makes that part valuable is the ability to interact with other people in real time. Other students maybe, or the instructor, but it's still real time communication. Yep.
I had an idea too, like one being during a class, have a button where you press it to kind of like raise your hand in class to signify that you want to ask a question, so you could talk or type it out.
Right.
And also having like office hours where there's like an hour or so that the teacher would just be there with the headset on, and if you need to talk to them, log in and you can talk to them like that.
So basically a block of time where the professor is guaranteed to be present, and then you guys can go online during that time as well and be able to interact with the professor during that time, more in a synchronous way than a asynchronous way. Synchronous means it's more interactive, like chatting is considered synchronous, but email is asynchronous, which means it might take the instructor a few hours to get back to you. Okay, well that's good information to know. Thank you for your input. Because I'm just curious, from your perspective, what makes it effective, or what are some of the obstacles of online classes. Yep.
What would make it more appealing is if, to add on to what she said, like if you were to offer this class next semester, if you just put all of the material all at the same time so that people could work at their own pace. I know, like, I think Harvard online classes, like the computer programming class does that. You could go on your own pace, but the professor will check with the homework every week. That way, I'm not sure if like policy would allow, but technically you might be able to squeeze in and accelerate your learning.
That was mentioned by another student in the previous class. I think that student was taking a music class where you can get up to, whenever you get up to like a certain number of points, you get an A out of the class. So you can basically do a homework assignment, not doing so well with that homework assignment, but you can do more to accumulate to the same amount of points. And whenever you get that number of points, you can tell the professor and say, okay, I think I got enough points. The professor will go back and evaluate everything and just say, okay, you're done, and you're done with that class. So you're basically talking about that type of self-paced type of structure, instead of, okay, it's week 6, we are now releasing these homework assignments, right? Okay, yep.
I had a question. With all the programs that, like you go into this class or any other class, why are there no markers set for problem areas? I mean, like if we were to ask questions about the problems that we come across on this, they're always the same. I mean, like when you go through math classes, people always hit the same points. But so the interaction that's always needed is pretty common, and it doesn't seem like a lot of the programs or online classes ever have anything that addresses that. So people are always looking for the instructor or face-to-face time to answer those questions when they should already be addressed at that point in the programs. That says,
only with the material.
That says, at this point, 95% of the class is going to want to talk to an instructor, but then it's just left up to students to find an instructor or inquire about face-to-face time, when the program should, or the curriculum should address that, because 95% of the students are already going to ask that question. That's what I see. I mean, if you ever go to like the MLC, the Math Learning Center, everybody always asks the same question at the same time, and The
I
tutors
think,
already
okay, I
answered
think
it.
I have the answer to
It's
that
a
question.
very common question.
Okay, so
and
let
the
me
problems
kinda-
are common.
Let me share the question with the rest of the class in case people back there could not hear you. The question was, because with certain classes like math or computer science, I think it applies more to technical classes than the non-technical classes. People tend to ask the same kind of questions, and how come that those questions are not addressed by the material, and why do these people actually have to find someone to talk to in order to understand those concepts? And I think I have the answer to that question because for certain concepts, and certain people, reading it does not help. They need somebody to be interacting. They need to be interacting with somebody to hear the answer, and also to listen to someone explaining it instead of just reading it from text. So I think it has to do with learning style, and that's different because our brains, even though they are kind of the same, but they're also wired differently, based on how we learn things as children. So that's why people learn differently, and some people want to get information by interaction, and some people can just read it and absorb that information.
I know that in Udemy.com classes, like for computer programming, it has like chapters by video, right? And then on the sides are the past people that took the class that had questions, and it gets attached to the video, and then the answers get kept there.
Oh, that is smart.
Frequently
That's good.
Mm-hmm.
asked questions get kept, so if someone new doesn't have to go back and ask. They could just see if someone asked it before.
So basically an FAQ, but it is associated with the
topic,
content of that particular topic. But that's a good idea. That is a good idea. Moodle actually has an ability so that you guys can create your own database as a class of questions and answers, and among other things. So that would be a kind of a cool feature for an online class. If you guys want to do it in this class, I can definitely enable that as well, so that you guys can share information while we are not in session during class. Okay. Very good. Thank you. Those are all kind of really useful information. All right. So we are now getting back with the projector. We can now get back to what we started off on the other day, and actually have the full recording of this thing. And of course, this is the entire thing. Oh well, this is most of the things that we talked about the other day. I'm gonna erase it and start from scratch. Well, because I want to kind of explain that whole thing again, while it is being captured, and also this will be a good chance for people who did not quite get some concept on Tuesday. Today is the second exposure to the same concept. So once again, you know what? I'm gonna use a different example this time. Okay. So this time I'm going to use a different kind of code. So it's a little bit different, but the process of analyzing it is the same. Okay, so that's the most important part. All right, so instead of using the piece of code that we have always been working on, which is finding the maximum of two variables, storing them into the third one, we're going to start with something that looks like this. It only involves one single variable. It's still a very simple conditional statement. Has a then branch, has one else branch. One doesn't really do anything, but I want to put it here just so that we can analyze it, the same way that we did. And we want to find out what is the post condition of this entire thing, okay, of this entire conditional statement. And since the projector is working, I'm recording everything, so this is a good time to actually, go through this one more time and then use the same technique to analyze this algorithm. The first thing we do is still to claim that the precondition of line 1 is true. Can somebody remind me what does that actually mean? In this case, we only have one variable, so what do I know, or what can I assume about that one variable x?
That is true value. Real value.
No. The true is applying to the condition prior to the execution of line 1. That has to be true. In other words, I'm simply saying true is true. Is that really telling you a lot of things? No, but that's the whole point. The whole point is I do not know a single thing about variable x. Okay? Because if I did, I would have told you x is greater than 20, x is less than -5. x is even, x is odd. I could have told you something about x if I want to start with an assumption about the value of x on line 1. But instead, I chose to tell you nothing. Okay, but I cannot just say pre1 equals to blank, okay, because it has to be a value that is true. So what is the simplest way to say something that is always true? True itself. Okay, yep.
So that's just saying that x is less than 0 is a fact.
No, it's saying pre1 is saying I know nothing about x.
So, I mean, you could put anything there. False, true, it doesn't matter.
No, it has to be true because we have to put something that is true. Okay. Now, if you say pre1 is false, it implies that the entire conditional statement is not reachable, which means it's a dead branch. We can't do a single thing about it.
So that's saying the whole entire whatever it's all true.
No, it's
not, it doesn't mean anything.
Okay, let's go back. Okay, that's a good question. Let's roll back and talk about the meaning of a precondition. Okay, the meaning of a precondition with respect to a certain line is saying, okay, what can I guarantee to be true prior to the execution of that line? So in this case, pre1 is saying, what do I know for sure that is true prior to the execution of line 1, which is the beginning of the entire algorithm in this case. Now, just saying that true is always true is saying nothing, okay, other than, yes, we can get here, but I know nothing about x. Yep, go ahead.
So to simplify that, it just means that true is saying that the condition is good.
Correct, it is reachable.
Yeah.
All right. But the emphasis is I don't know anything about x, okay? In other words, this is not about tracing the algorithm. It is about analyzing the algorithm to figure out what it is actually going to do. All right, so let's go to line 2 then. Okay, pre2 is basically saying if I am about to execute line 2, what can be guaranteed when I'm about to execute line 2? Now, from the structure of a conditional statement, what do we know when we are about to execute the beginning of the then branch?
True.
What is true? The condition of the conditional statement has to be true. Is that right? Okay. So the way we express that is, now in this case, I want to be as general as possible first, and then we'll work our way to make it more specific. In this case, I would say this first. The precondition of line 2, which is the condition that is guaranteed when I'm about to execute line 2, is going to be this. Pre1 still has to be true, because how did I get from line 1 to line 2?
Because line 1 was true.
Line 1 does something, a comparison. Line 2 is over here. So did I have a chance to modify any of my variables, or this one single variable in this case?
No.
I didn't have a chance, right? So whatever was true before line 1 executes still has to be true right before line 2 executes. Is that making any sense? Okay. So that's why pre1 is a component of pre2. But on top of that, because this is the then branch, I cannot get to the then branch unless the condition of the conditional statement is also true. So that means x is less than 0 also has to be true in order to get to line 2. Is that okay? So knowing these two things, then we can say, oh, pre1 is just true because it's given to me as that, and then x is less than 0 is x is less than 0. And now we can do the simplification and just say that true is true and whatever is just whatever. So we keep x is less than 0 and simplify the expression.
So how did you determine that it was true? How did you get past pre1 that it was? Because it has to be true.
Because that's established before.
So pre2, you said x is less than 0 has to be true. How is that determined?
No. Well, it says right before line 2 executes, this condition is guaranteed. It's hypothetical. It's not a trace, so we're not actually using a specific value of x to get here. We are simply asking, according to the structure of this code, if I ever get to line 2 and about to execute line 2, what can be guaranteed? Well, x is less than 0. Go ahead.
I was just gonna say it because I think I knew why he wasn't getting it, because he was like, because we don't know what x is, so you wouldn't know if you were to do it. But as you said before, it's if we were able to do it, what would be true?
It's hypothetical.
Yeah.
It's basically, I'm trying to make a statement that has to be true about whatever x is at that point.
If it meets the conditions.
Right. Now I can make I can use an example here. Okay. So the example involves a room like this, and there's a door. Okay. And the door here on the outside, says, man, it's a bathroom. Okay. It's a bathroom. So if the occupancy sensor, is tripped, inside this room here, what can I say about this person here? Right. Exactly. Now, how do you know that this has to be a man? Well, because it's a condition, right? To get into this, bathroom, this is a condition. So I don't even need to know who this person is, but that's one thing I know for sure is the gender of that person. Is that okay? All right. So it's really the same thing here. I don't need to know exactly what the value of x is. What I'm asking is, if I am about to execute the then block, what can I assume at that point? And because of the structure of the conditional statement, that is what I can guarantee.
Yeah, the x is less than 0.
Sorry?
The x is less than 0.
The x is less than 0. Right. Okay. Yep, go ahead.
In the last line, where did the t go away?
The t goes away because it is true and whatever, and it simplifies because true is the identity of conjunction, just like 1 is the identity of multiplication. So true and whatever is just the whatever. Yeah, you can do the simplification. Now let me just go back and change a little bit here. Okay, I'm going to start with something a little bit different, which is x equals to k. Okay, so sorry about this, but it makes even more sense when we do something like this. So we just start with something like x equals k, but what is k? I don't know. Okay, I just know that x and k are the same on line 1. Okay, prior to the execution of the entire algorithm. So that means when I have pre1 and x is less than 0, I can no longer make that simplification because I cannot take x equals k away. There's no way to simplify that one out of the condition. So I still have a bigger condition here. All right, but later on we'll see why it is useful. Go ahead.
How do you write that on a spreadsheet? Like if you're turning it in as homework?
This homework will require you to turn it in as a Word document or a word processor document and not as a spreadsheet. Yeah. That's a good question. All right, so knowing this is the precondition of line 2, what do you think is the post condition of line 2? Okay, now this is kind of tricky, right? Because line 2 definitely is, well, maybe it will make some changes to x. Okay, the question is, knowing the value of x after line 2, can I use that to reestablish its value prior to line 2? Yeah, negation is reversible, isn't it? Okay, so now let's go take a look. Okay, so what can I say about x after line 2 executes? Before line 2 executes, I know x equals k and x is less than 0. After line 2 executes, what can I say about x in relationship to k, for at least? Keep typing the wrong thing. Okay, so what can I put on this side of the equality?
Still be equal to k.
X
No.
equals negative x.
Negative, yep. Either way is fine. You can say negative x is now k, or k equals negative k.
Oh, yeah.
Right? Because this is referring to the value of x after line 2 executes. So if x equals k before line 2, immediately before line 2, and line 2 is negating the value of x, that means after line 2 executes, the negation of x becomes k, or equals to k. Is that making any sense? Okay. What about the other part? What can I say that is less than 0?
Okay.
Negative x, right? Because if x was less than 0 before we take the negation of it, then after the negation, if we just do the double negation, it still has to be less than 0.
So
Yep.
for line 2, the negative x, should the negative x be on the other side of the? Because you're just, if I'm reading that right, negative x is just going to get changed to x, which is a positive value.
So wouldn't it be greater than 0? Because a negative, if
So
x
it becomes greater than 0.
if
That
it
is
starts
correct.
negative and you put another negative, the negatives cancel out.
So it's
that's
okay
fine.
to-
Or-
No, because the
Oh.
x value gets negative x, it just gets written over.
Because the evaluation is, you start with the right-hand side, you evaluate the value of the right-hand side, and then you use that to overwrite the left-hand side.
So okay, so how did you get negative x on line 2? Because you haven't done a command line to say that x is going to be negative. You just have an x on line 1.
Hold on.
Negative value.
The only reason why we can even get here is because x is less than 0. Otherwise, we would not be executing line 2. We'd be going
So you're just
to the
going.
other
You're
part.
free to add the negative once you know the condition of like x of line 1.
Okay, if you look at the picture,
Yeah.
it means, the structure is static. Okay, the structure of this thing is static. In other words, this part here says x is less than 0, and at this point we say x equals to k. Okay, that's the condition that we know. Okay, so the question now is, if you just, you have a slip of paper with the actual k, right? The actual value of x. So you walk down this path, and if I see you here, okay, what do I know about x?
It's smaller than 0.
It's less than 0, because otherwise you wouldn't be here, right? And what you will do here is to say, okay, let's take the negation of x and then use that to update x, right? So after the operation, when you're just about to exit this block here, what can I know about x at that point? It'd be greater than 0, wouldn't it? So that's basically what the post condition is stating, is if I see you here and you're holding a piece of paper with the value of x, what can I say about that value of x? It has to be greater than 0. I don't know the detail of that. Okay, it can be 1, can be 5, can be 10. That I don't know, but I know it has to be greater than 0. Okay, but I can also relate it to k, because I know that when you come in here, because of this assumption, I know when you come in here, x and k have the same value. But when you're exiting, because of the operation specified here, I know that x at that point will be negative k.
Oh, I understand that part. The part I don't understand is you just added a negative sign. Now, if I'm getting it right, just because I know if x is less than 0, I know it has to have a negative number. So it has to be a negative something. So I'm just free to add that negative in, knowing that that's what it is. Like that's.
Would that make it better?
No, he's taking the negative value and turning it into a positive value.
Oh, I understand. That's the part I understand. You're adding the negative sign. That's the part that that's like, you're writing a line of code, and the next morning you add a digit in there, and that whole digit can throw everything off.
No, it's an operator. It's not a digit. It's an operator.
Okay.
Because the negation of x is the same as saying 0 minus x. It's the same thing. It's just a shorthand of that.
Okay.
Yep.
Yeah, when you add the 0, it makes more sense.
It's the same as that.
It's just adding an extra. It's you don't add stuff to a program. Or like, I don't know. Well,
Think of it like multiplying by -1.
yeah.
Right. That works as well. But in mathematics, if you use negative as what we call a unary operator, which means it only has one number to work with, it's negation, which is just taking the sign of the original number and flip it. If it's positive, it becomes negative.
Yeah.
It doesn't do a single
I
thing
understand that
to
part.
0.
That's like the only thing that had me confused was you're adding
Oh, okay.
a negative sign.
So maybe it's just a
I
notation.
understand that it is negative,
Okay.
but you're adding it to the code. Like, should you be doing that?
The right-hand side is just an expression, right? So taking the negation of x is an expression.
Okay.
Yep.
So either answer would be correct. Negative x is less than 0 or x is greater than 0. It's fine.
Negative x is less than 0 or x is greater than 0. They're identical. They're equivalent. But I like to keep it like this because I just modify whatever was x before is now just the negation of x. Okay. And it will serve a purpose later on too. What about pre-4? Okay, what can I say at right before I execute line 4? In other words, in the picture, if I find you right here, you're just about to enter the block of the else part, what do I know for sure if I find you there?
X is greater than 0.
Okay, so let's start with the pre-1 here. Okay, pre-1 still has to be true. In other words, x equals k still has to be true when you are here, because I can get here just by a comparison, which does not change the value of x. On top of that, the condition of the conditional statement has to be false. So we start with something like this: the negation of the condition of the conditional statement, and then we can expand this. Pre-1 is x equals k. Not x is less than 0 means x is greater than or equal to 0. Don't forget about the equal part. Okay, there we go. So here's pre-4. Is pre-4 making any sense? Okay, and what does line 4 do? It's a trick question. Nothing. Okay? Absolutely nothing. Okay, we take x and then you say, oh, use yourself to update this yourself. Doesn't do a single thing. So if a statement doesn't do a single thing, what is the post condition?
The same as the pre.
Same as the pre, because it doesn't do a single thing. Now the reason why I put it here, that I even put it here, is because if I don't have an else case here, it makes it a little bit harder to analyze the outcome of the entire algorithm. This makes it easy. But before we go any further, does post 4 make any sense to you? That it's the same as pre-4.
Does it matter if you put pre-1 instead of pre-4? Or you have to put pre-4?
It has to be pre-4. Because pre-1 only states x equals k, but pre-4 adds on top of that x is greater than or equal to 0, which is because of the structure of the conditional statement. Okay, so now we go to post 5, which is where you find me drunk with a bottle of liquor. Okay? And I have no idea, absolutely no idea how I got here. But I look at the sign on the path and I know that this is one way, this is one way, and that's one way as well. So I know if I'm drunk here, I have to be coming here through one of these two paths going into that junction. So what can I say as post 5?
Post 5 equals post 2 or post 4.
Exactly. Now this time, just using a regular or instead of either or becomes even more important. So let's take a look at why that is actually important. When you use the word either or when you use the phrase either or, it means only one can be true to make the entire thing true. When you use the word or by itself, it means at least one has to be true. Is that making any sense? Okay, so let's take a look. When we expand post 2 and then expand post 4, we'll take a look here. If I expand post 2 is this mess here. You just copy and paste it. And then post 4 is this mess here. And then we'll copy and paste it over here. All right. Okay, and then we just focus on this statement here and compare it to the original. What do you think is this algorithm is actually doing? What is the one thing that is common in both cases?
Makes x or k positive.
Well, x is greater than 0. Greater than or, x is greater than or equal to 0 afterwards, right?
Yes.
In both branches, okay, your one branch guarantees that, one branch says x is negative x equals to k, and oops, x itself is greater than 0. The other one says x is greater than or equal to 0. So x cannot be negative at this point from either branch. Okay, it doesn't matter which branch I come from, but x cannot be negative. What do you think this entire code is actually doing in mathematics? Is there a math operator that can accomplish exactly the same thing? Absolute value. Exactly. That's actually doing absolute value. Yep. Because when you take the absolute value of a number, you're basically saying if it's positive, keep it the way it is. If it's negative, flip the sign. And this is exactly doing that. So are we okay with this concept? How we analyzed the conditional statement? It's a question. Go ahead.
slightly confused on the very first line, x is less than 0, which is supposed to be true.
Are you talking about line 1 of the pseudocode?
Yes.
You're referring to this one here?
Yes.
No, that is a question.
That's just a question.
That is a question on your trail to help you decide which way you're supposed to go. Okay. All right. Yep.
I don't know if you already, or if I just forgot it, but what does K represent?
K just represents the quote-unquote old value of x, and that's how we can make this. That's how we can make this statement down here. Okay, so now let's not look at the conclusion here. Let's think about how you would describe the outcome of using the absolute value operator. Okay. In other words, if I tell you that x equals k, how would you relate the absolute value of x to everything else? Okay, it's non-negative. Okay, all right. So the absolute value of x is non-zero. But that's easy. I can just make absolute value of whatever map to 0. That is always greater than or equal to 0. So there's one little requirement that is not met just by saying it is always greater than or equal to 0. What else am I missing here? Has to equal to
Positive or negative k.
And
okay, but which one? Okay, but there's only one time when it's supposed to equal that. When? Okay, I should probably using k instead. I mean using x here. This only happens when x is greater than or equal to 0. Okay. What about the other case? There's something else that I have to state. What if x is not greater than or equal to 0? Then the absolute value of x, how does that relate to x? That describes, the properties of taking the absolute value of x, right? So now the question is, if you take a look at this expression here, this logical expression, does that mean that is that doing this? That's the question. Now, the purpose of k is simply to state the original value of x, where x itself is supposed to be the absolute value of x. So when you look at this outcome here, okay, let me just I'll just write everything on the projector. Okay. So the definition of the absolute value of x is, okay, one way to describe it is the absolute value of x equals x and x is greater than or equal to 0, or the absolute value of x equals the negation of x and x is less than 0. Right? That has to be true to describe the absolute value of x. Right? Now this actually implies the other part already on the whiteboard, which is the absolute value of x has to be greater than or equal to 0. That already guarantees that. Okay? So now the question now is this algorithm coming up to this conclusion going to be doing the same thing as taking the absolute value of x? The purpose of k is it is the original value of x. The new x here, which is the x after line 5, is actually our absolute value. So the question now is, if you look at this whole thing, it is basically saying the negation of that and this, and then we have x is the negation. Okay. that's basically what we're comparing. We're comparing this one here with this one here. Are they the same? Are they staying the same thing? What do you think? You can flip the signs a little bit, move one to the other side. Okay, the first thing I can do, is to change the sign here. So in here, I can say this is absolute value of x equals the negation of x here. And then the other side is the negation. That's just says here the. Oh, okay, that doesn't work.
Yeah, it does, because when you multiply by a negative, the greater than or less than sign is good.
Right. So have to relate it to the original value. Does it work or does it not work?
It works.
Is this, which is the conclusion of our algorithm, implying that which is the definition of the absolute value of x? Okay, this says, x, the absolute value equals to the negation of x, which is saying the same thing. And let's see.
What is happening?
I'm missing one thing here. Okay. There's one thing I'm missing here because the one part that I'm missing that makes this not work, it has to do with this part here. Now when I make this conclusion here, there's one thing I can add to this part. If I know that x equals k and x is less than 0, can I also say at this point that k is less than 0?
Yeah.
That's what I'm missing. Because if I have this part and add it back to here, then it will match this part exactly. But this is actually important because this statement or this condition here that k is less than 0 is already implied, but it is no longer implied later on after the operation on line 2. Is that okay or not? Yep.
Wait, so wouldn't that be a negative though?
Yep. Now let's go ahead and propagate this change. Okay, I'm going to propagate this change here. Now the fact that k is less than 0 is okay. We can just keep that in the post condition of line 2, because line 2 affects x, not k. So the fact that k is less than 0, hey, we can keep it around the whole time. So that means in the case of pre-for, we can also just make a conclusion and say that k is greater than or equal to 0, because x equals k and x is already greater than or equal to 0, and as a result post-for is the same way. K is greater than or equal to 0. So now when we look at the conclusion, we just add that one extra piece, which is saying this, in this case it's saying k is less than 0. In the other case it is saying k is greater than or equal to 0. Are we still doing okay at this point? I'm just going to change the font size so that we can see the entire thing. There we go. Is that part okay? I just added one thing that was implied by the other parts of the same statements. But once I have this, remember what k actually stands for. K actually stands for the original value of x. So that means if I make the translation, this means x itself is less than 0 in this conjunction. And in the other one, it simply makes the assertion that x is greater than or equal to 0. So now, if you look at this statement, does that imply this statement here? That should be pretty clear. Yes or no? Yep. Now it's the mechanism itself, is kind of tedious, but what about the overall picture, the objective of this whole exercise? What was the objective again? Why did we go through this whole process? To find the post condition and to make the post condition, to see if the post condition matches what it is supposed to be. Okay, and what if it does? Like in this case, Okay, what if it does? What is the significance of having the post condition of this entire conditional statement matching how you would otherwise describe taking the absolute value of a certain number?
The algorithm works for all cases.
The algorithm works for all cases of x. So if I am writing this software, what does that tell me? Do I have to test it with test cases? Nope. That's it. That really is the significance of this entire exercise. We are kind of, we spend a lot of time to talk about the details, how do you derive from one line to the next. But the significance of all of this derivation is simply to say, hey, you know what? I just proved that this algorithm will work for all values of x. I don't need to test it with a single test case at this point, because it is guaranteed to work. Okay. Would that be a useful thing to do if you can apply this technique to entire programs? Yes.
Yeah.
Yep.
You're gonna have a lot of time on your hands.
Or a lot of people at your disposal. Because this is difficult to do. It is called software verification. Okay, so let me just kind of look up the name here so that you can see, how it is used in other contexts. It's called verification. It's a field in software engineering. So there we go. And let me bump up the font size here. Okay, yeah, go ahead. I forgot about the roll sheet today, so, I said it earlier today. Yep. In software project management, software testing, and software engineering, verification and validation is the process of checking that a software system meets specification. Now, what exactly is our specification in the context of what we just did?
The positive value.
This is our specification. The program is supposed to accomplish that. Okay, that's the specification. So the question is, does the software system meet the specification and fulfill its intended purpose? Once again, it's the logical expression. It may also be referred to as software quality control, normally the responsibility of software tester and the software development life in the software development life cycle. If you look up this and Prolog, verification and Prolog, but misspelled here without a UE at the end, you can, I'm not going to read this whole thing here, but it's interesting because people actually wrote an entire programming language called Prolog for the purpose of automated program verification. That was considered the holy grail of AI, I would say back in 87 or 86, in the mid-80s. In the mid-80s, there was a fierce competition between the United States and the Japanese to build the quickest and the fastest computer. And they were trying to apply AI, and one of the area where artificial intelligence was trying to do, or trying to accomplish, was program verification. We want to be able to make sure that a program works the way it is supposed to. And it's still a holy grail because this takes a lot of processing power, because it took us, just manually, it took us a long time to prove the correctness of a simple conditional statement. Can you imagine how long it would take for programs that are millions of lines long? Yeah, it's going to be very difficult, right? But the process of doing this is helpful when you're debugging your program too. Yep, go ahead.
I was going to ask, like on a test question, going back, would it give you the specification?
In the test, I will make it easier. In the test, you just have to go through a mechanical process to derive the post condition, and you don't have to match the post condition to the specification. In other words, I won't even give you the specification that you're supposed to verify. You just have to procedurally go through the code and figure out what is the post condition, which is considerably easier compared to what we just did. Okay. All right. So there's one more statement, one more kind of statement that we have not mentioned. We talked about assignment statements. Okay, we got that. We talked about conditional statements. We got that. We haven't talked about multi-branch conditional statements, but that's kind of like an extension of normal conditional statements, so it's not a big deal. The one type of statement that we have not talked about yet are, come on, what is the previous homework assignment?
Nested?
Loops.
Oh.
Okay, a loop. Okay, now a loop is kind of difficult. So let's go ahead and take a look at a loop in the context of deriving pre and post conditions. So I'm going to start with a new program here, and let's see. Okay, so this loop is going to do this. Okay, while x is less than k, do x gets x plus 1, line 3, and while. Okay, it's a very simple 3-line program that is a loop. And of the 3 lines, the last line is not even useful because its only purpose is there to end the construct. So the question is, how can I derive the post condition of this entire loop here? Okay, and people might look at this and go, well, there are only 3 lines as opposed to 5 lines of the previous conditional statement. So this one has to be quite a bit easier because there are not nearly as many lines. Well, it depends on how you look at it. Let's draw the picture of a loop first. So this is a while loop. The problem with a while loop is it has a loop. There's a way to go back to the beginning. That makes it harder to analyze. Okay, so now that's going back here. Okay, that's a basic structure of a while loop. We check the condition first. We have a chance to get out of the entire loop, or we might go perform the operation specified in the loop and then go back to the beginning. So in this particular case, the condition is x is less than k. If it is true, then we go through this operation. If the condition is false, then we get out of the loop. In here, we say x gets x plus 1, and then we go back to the beginning and then go through that process all over again. Is that okay so far? Okay. So if I tell you that the precondition here, which is pre1, is just true, okay? In other words, I don't know anything about x or how it relates to k. Okay, so I have no idea how these 2 variables relate to each other. What can we say at this point? And by the way, the decision-making point is right here. So this is before we make a decision.
True.
Nothing. Not yet. Okay. Let me just redraw this picture. I didn't draw it the way it's supposed to. I have to redraw it just a little bit so that I can put a circle to some place that is actually very important in this analysis. This part here. Okay. What about this part here? If I want to label this part, what would it be? It's not pre1. It's pre2. Now pre1 is not the same as pre2, unfortunately, in this case. This is pre2. The precondition of line 2. In other words, what do I know for sure right before line 2 executes?
X is less than k.
Okay, pre2. Okay, one thing we know for sure is x is less than k. Very good. Good job. What else do we know about this? Sorry?
Pre1 is true.
Pre1 may be true. Okay? Now, how do I know pre1 may be true? There's a merge point prior to this. The merge point is here. Right? In other words, we can get to this point as the first iteration, and we haven't gone through the loop at least once. Or we could go back to this point after we get around the entire thing.
And that brings us back before pre2.
Exactly. How would I label this? If I just label it, for documentation purposes, how would I label this point here? It's post 2. Okay, very good. So that means there are 2 things that can also be combined with x is less than k. Now x is less than k has to be true, otherwise I wouldn't be here. But there are two additional things that can also be true. One has to do with pre-1 itself, right? And then the second thing has to do with post-2. Is that making any sense? Now, but with this, it's kind of hard to derive post-2 now, is it? How would you describe post-2 if that's pre-2? Okay, now let's go ahead and make this a little bit easier now. This part, what is pre-1 again? Pre-1 is true because we do not make any assumptions, and then we have post-2 here. What do you think is true or whatever? What is the property of a disjunction? How do we make a disjunction true? Or. If at least one side is true, the entire thing is true, right? So here we have at least one side being true because it's just true itself. So that means the entire thing is true. And anything and true is just that anything itself, which is just x is less than k. Okay? All right, so that's fine. Yep.
So we have to show those 3 steps, or if we just put just x is less than k?
Show those 3 steps? Oh, you need these 3 steps?
Yeah.
There won't be any questions, asking you to analyze loops, because loops are actually considerably harder to analyze compared to conditional statements. So you don't have to worry about this. But if I were to do this, I would do it, step by step, and that's how I would do it.
Okay.
All right. What about post-2? Knowing pre-2 is this, then what is post-2?
X is x plus 1.
Okay, we did x gets x plus 1, right? And we know before line 2, x is less than k. So what can we say about x and k after we increment x? What can we say about a new x, the new value of x?
Bigger than less than.
Can we say that?
Yeah.
Yep. Because x got incremented on line 2, so if we reverse that operation, then we can reestablish how x relates to k. Is that making any sense? What
Basically,
there are other ways to say that. You can say x is less than k plus 1. Okay, you can also say it that way. But that's just algebra. Bring the negative 1 on one side to the plus 1 on the other side. All right. And then what about post 3? Post 3 is trying to say, what do we know at this point?
X is greater than or equal to k.
X is
Greater than or equal to k.
greater than or equal to k. Now, how do we know that?
Because it got out of the loop.
It got out of the loop. Okay, so because of the fact it got out of the loop, the condition of the loop has to be false, right? Which is the negation of x is less than k. Is that making any sense? But there are other things that can also be true at the same time. What else can be true at the same time? So once again, there are 2 ways to get to the exit of the loop here. Because not knowing how k and x relate, it is possible that I can go through here, not go through a single iteration, and end up here directly. Is that making any sense? So that's one way to get to post 3. The other way is to go through at least one iteration, and then we decide to get out. So those are 2 ways to get out of the entire loop here, which means by the structure of the loop here, it is possible that I have to put post 2 here. It is also possible that I have to put a pre-1 here. Am I making any sense? Post 2 is here because if I go through at least one iteration, post 2 has to be true by the time I get to the exit point of the entire loop. Pre-1 can be true because if I skip the first iteration, in other words, if I do not even perform one iteration to get here, then pre-2 is still true at that time, is guaranteed because I haven't got a chance to modify anything at that point. So if you go through this analysis, it will still give you almost the same kind of result. So this part is here, and we can simplify this to x is greater than or equal to k. And then on the other side, we have post 2, which is x minus 1 is less than k. And then this was just true. Okay. And in this case, we can do the same simplification and say that this is x is greater than or equal to k and true. And anything and true is just that anything here. So x is just guaranteed to be greater than or equal to k. All right.
On post 2, when you have x minus 1, if they had to go through the loop like 3 times, would you put x minus 3?
We don't know how. No.
No, I mean, I'm just like, we already know the values of x and k. But let's just say it had to go through 3 times to get out of the loop. Would you put x plus 3 or minus 3, or would you just leave it as 1?
I'll leave it the way it is.
Time, so it'll stay the same.
Because it is in relationship with pre-2 here.
So
This is a minus 1 because because x was less than k before it got incremented.
Also, after each loop, the x would change, so it'd still be the minus 1.
Right.
Okay.
Yep. Okay. Now, we can make some changes to this one and make it more, kind of more interesting. So what if I change the precondition of line 1? Instead of saying I know nothing about it, now I say something about this and say, oh, you know what? I know that x is less than k to begin with. Okay. So how would that impact the entire thing? Okay, let's go ahead and rederive everything. Okay. So we'll go to pre-2 here. The first part of pre-2 derivation, which is this part here, is not going to change because the highlighted portion of pre-2 is due to the structure of a pre-checking loop. Has nothing to do with this specific loop here. So I can keep that part, okay, just fine. So x is less than k and pre-1 or post-2. Okay, so that part I can keep because it's the same structure. But when I expand pre-1, then I cannot use the same thing because pre-1 is no longer just true. It is now saying x is less than k. And post-2 is still going to be here. Am I doing okay so far? If I change the assumption of pre-1, I can no longer do the simplification that I did before. And then how do I simplify this? Before, I was able to simplify because pre-1 was simply true, and then true or whatever is always true. But now, x is less than k is not going to, I cannot do any simplifications. What if I use the distributive property here? Do you think that would help me? It helps me a little bit, but not entirely, okay? Because what happens when I apply the distributive property? The distributive property will basically say this entire thing is going to be the same thing as x is less than k and x is less than k, or x is less than k and post-2, right? That's the property of the distributive property. You can look at this as multiplication, this is addition, and we can do the same kind of thing in arithmetic by expanding it. Is that making any sense? But is that really helping me? No, not exactly. I cannot get rid of post-2. In other words, I still have x is less than k here because x is less than k and x is less than k is just x is less than k. And then we have the other side, which is x is less than k, or post-2. When you look at this side versus this side here, which side is more restrictive? The left-hand side or the right-hand side?
Left-hand side.
The left-hand side is more restrictive, and because this is an or, we have to keep the side that's more general. In other words, the best I can do is to simplify it to x is less than k or post-2. In other words, I cannot get rid of post-2. Post-2 is still here. So does that mean that, how do I derive post-2 when pre-2 involves post-2? The answer is, I cannot. Actually, okay, I take it back because Well, okay, I take back some, but I made a mistake here. That's supposed to be an and. That's supposed to be an and here. But the point still stands that I cannot do any more simplification. And so if I want to derive post 2, I have a problem now. Because post 2 it depends on pre 2, but pre 2 in return depends on post 2. So we have a little bit of a loop here. Okay? It makes sense because we are dealing with a loop. If we cannot resolve this, then by the time we get to post 3, we have the same problem because post 3, which is the entire post condition of this entire loop, also involves post 2. So even though pre 1 is already figured out, we know this one is just x is less than k, we are stuck now, okay? Because we cannot resolve post 2. So on next Tuesday, what we'll do is we'll look at this again, and then we'll find a way to solve this problem. Okay? How do we fix this problem when we self-referencing
I'm so glad you record these.
Oh.